Hello everyone, welcome back to the channel. Last week we participated in a hackathon. Our team built an AI agent platform that generates test cases automatically from requirement documents, Jira tickets, from source code, from database schemas. And it placed first in our internal hackathon. In this video, I am going to I am going to explain how this SaaS application we built within 4 to 5 hours, and what is the follow structure we have to follow in hackathons to win first place, and how to impress judges. What are the precautionary actions we have to take. The best follow structure definitely wins and definitely impresses the judges. What is the environment variables, how to create, what is the git ignore, how to implement guardrails, and how to implement multi-rag pipeline systems to build this type of SaaS application, right? uh, let's If you want to walk into your next hackathon and win it with an agent platform like this, stay to the end. Yeah, actually our problem statement is this one. Like, in general, QA testing is repetitive and manual. Every project needs functional test cases, boundary test cases, security tests. And if you are a developer, you need unit tests. And if you are on the data side, you need reconciliation tests for ETL pipelines. QA Forge is one platform. The QA Forge nothing but the test case generator assistant. What we developed, one platform that reads any of these input types. A requirement document, it will read. A Jira story, it will read. A Python file, it can understand. A Java class, it can understand. A SQL schema, it will understand. An open API specification related requirement, it will understand, and generates the right kind of test suite automatically using an LLM agent pipeline, not just a single prompt. Let's go to our actual application. What we developed in the hackathon lab. This is actually in lab we developed with Streamlit UA, talking to a fast API backend, and talking to an OpenAI powered LangGraph agent backed by a vector database and a SQL history store, all running in Docker. Actually, we deployed Docker containers on render. Let's see it work, then I will show you exactly how it builds. Okay. uh, let's start with here, new project. Here, three different apps, their test cases never mix. So let's create new project. For suppose HDFC banking project you are working for. Yeah, we created. Now let's see. Here, this is the generate test cases page, and here we can upload documents, and here this is the dashboard. It will show the results, whatever you generated. And here also you can create new project from here, or here you can create. And now let's see, let's upload the documents. For suppose I have some, 1 second. Yeah, banking requirements is there. So I am uploading, I am ingesting the data. Yeah, I ingested. Let's once here you uploaded the documents, no, here generate test cases, you can go. Actually previously I did some sample tests. So here 3 times. So whatever the documents you uploaded, here you can see. Now let's create the document. Let's click on the document, and here, 1 second. Here what happened, see, 23 chunks, right? This chunks the file and embed it into a vector database, like Chroma here views, so the agent can retrieve relevant context later. Once you ingest data, it will be split into chunks, and that will be stored as embeddings in the vector database. So that can retrieve relevant context later. That's it. Now, here let's go to generate test cases. Here, see, 6 engines. One is manual QA, Python unit, and Java unit, SQL unit, and ETL and API. Here, users must be able to reset their forgotten password via an email link that expires after 30 minutes. One requirement I am going to give, like for suppose manual, you have description. For suppose you have description. What is the description? Users must be able to reset their password, forgotten password, forgotten password, manual testing related via a email link that expires after 30 minutes. Minutes, right? Let's create, instead of documents, let's generate test case. Here, see, watch this: detect engine, plan coverage, analyze input, generate cases, validate output, tag risk. This isn't a fake loading animation. It's live progress from the actual LangGraph pipeline running on the back end, streamed step by step. I will show you exactly how that works in the code section. Okay. See, yeah, it's generated and it will show like this. You can export this Excel or PDF. For suppose PDF. See, like this it will, like this. See, test case. It will explain everything like this. Okay. Now, like this you can. Also, you can interact with Jira. We configured Jira also. I created one personal Jira account, and I create one story. My story ID is Scrum 5. Scrum 5 is my Jira ID. Here, instead of typing a requirement like this, we can paste a Jira story ID or even a full Jira URL, and it fetches the issue directly. Like, let's see here. This is the Jira ID I given, like this. Detect engine, plan coverage, analysis input. Yeah, like this it will generate. Like this it will show. You can export and you can see the results in the PDF file, right? Now, this is the functionality for any test case it will work. And if you want to select some test cases only, here you can check. You can check what functional test case you want, boundary test case you want, negative test case you want, security test case you want. You can select accordingly. You can select all at a time, like this, right? So this is the interface, and some extra features are there. We can change the theme also, like this. Um, Notifications it will show here, and if you have any doubts in the requirement documents, here you can ask whatever it may be. You can ask questions also here. This is a chatbot option. Models provided in the context was password reset and user authentication. It will answer accordingly. This is the chatbot we created. So how we created? See, this is the dashboard. It will show everything like this, colorful and functional boundary, how much percentage it will show. Now let's see the folder structure, how we created. First of all, what we did know here, QA Forge. What is this? Before any code, any code was written, this file existed. This is the single source of truth. It defines who uses the platform, what tech stack, the exact folder structure, and a phase by phase build plan from phase 0 to phase 10. Even when an AI assistant helps you build something, you need to understand and own this document. It's the specific you are accountable for, specifications you are accountable for. Let's see here. This is the user. This is the user table guide. Like it is helpful for QA engineer like Python developer, Java developer, SQL developer, retail developer. One platform, six audiences. The tech stack line. What are the tech stack? Here we can see tech stack whatever we use and rules. So we by this single MD file we build this entire application. That's it. Simply we can tell. And this is the folder structure. Page 0 project skeleton. In the page 0 we created folder structure. Folder structure is very very important. Okay, let's understand the shape of this project before opening a single line of code. Let's see here. App is the main, like all backend logic, everything here it matters. Configurations like settings and LLM client factories where secrets and model configuration live, and ingestion loaders and chunkers for every input type, the vector store and the rag retriever for knowledge, and a LangGraph pipeline itself, like the LangGraph pipeline itself, like state, router, planner, analyzer, validator, risk, and the graph assembly. It will be in agents. See here. And memory. Let's like memory caching and persistent history, and guardrails, input guardrails, output safety checks, and APIs, the fast API app and it routes, and services like export logic like SQL, Excel, PDF, zip bundles, everything you can see in services here. And observability like logging and metrics, and tools here. Tools we created. Tools here. Jira and retriever tool. Jira client tool and retriever tool. And UA is for here in a hackathon we implement a streamlet, but Next.js also we can use data samples like synthetic data. It will create synthetic data to check, and evolves nothing but the golden test set and evolve runs, and test folder is for the deterministic unit test. No LLM calls, fast, run in continuous integration. And docker is nothing but we created docker also just for deployment purpose. Okay. Here, one thing to notice, every folder name is a noun that describes one responsibility that's not accidental. It's what lets you open this project code like after 6 months later and know exactly where to look. That is. Now let's go to project page 0, that project skeleton. Here, every project starts the same way: a virtual environment, a Git ignore that keeps secrets and generated files out of version control, and a requirement files like look at like see here Git ignore. Here Git ignore .env, .chroma, cache, SQLite output. None of that belongs in Git dot. Like secrets and generated data are the two things beginners most oftenly accidentally commit. These should not be commit, right? This should answer to the judges. What is the important of dot git ignore? So you have to answer like that. Like these should not be whichever files you don't want to commit in Git. Those we can put all these in the dot git ignore file, so it won't commit. And here requirements document we created. What is it? Here LangChain, LangGraph, ChromaDB, FastAPI, and the Streamlet, struct log, the client. This one file tells you the entire text stack before you read a line of code. And in the part of phase one, that is configuration here in apps, in app folder, configurations here, configuration is there, and settings is there. In settings here, what we did, we configure everything. Like here, what happened, this uses pydantic settings, a typed settings loader that reads from a .env file. Here, why not just os.environ.get everywhere? Because typed settings catch mistakes at startup, not at 2 a.m. in production when a variable is misspelled. So that's why we created this pydantic settings. This is the settings.py. Okay. No worries. I will give you this code. Everything I will give you in the description. You can check in your personal laptop, and you can explore. You can maintain this type of folder structure in upcoming hackathons also. Definitely you will win. And also here, see here, field validator is there. Here, that strips white space from open API key. Here, this one line exists because of a real bug we hit. Here, I will tell that story properly in the deployment section, but the short version here, a trailing new line in an API key pasted into a cloud dashboard silently broke every authenticated request for hours. Defensive code like this is what production experience look like, right? So this field validator helps in the production environment. So that's why we created this. And let's go to models. Here, what it is. This is the only place chart OpenAI and OpenAI embeddings get constructed. Why centralize it? So when we need to fix a connectivity bug, I will explain that too later. We change it in one file, not 15 files. Here, this is the model configuration related things, right? We imported and LLM related logic we wrote. Temperature, float, everything. Temperature is 0.2. Temperature nothing but the degree of randomness. It controls the degree of randomness. So that is called temperature, right? This is the here models related. We write the code. Now let's go to ingestion layer. Ingestion layer, and in this ingestion layer we have chunks. We can see the chunks. Here, what is this? Here we followed three chunking strategies. One is recursive for plain text, structural for splits by heading for documents, and table for spreadsheets. Why three? Because chunking a Python function and chunking a paragraph of a requirements document need completely different logic to stay meaningful when embedded. That's why we created here recursive chunks, structural chunks, recursive chunks for plain text, structural chunks for documents, and table chunks for spreadsheets. So this type of production ready setup, we have to uh, develop the code accordingly, like this. So in hackathon we built only for pdf documents only, but this is the hackathon, they asked only for PDF related requirements, but we implemented not only PDF, any document, any STM files, Excel files also we can read. So that's why we call this as a multi-source ingestion. Multi-source, multiple sources we can ingest documents, PDFs, Excel files, everything we can ingest. Once it was splitted into chunks, what will happen? What will happen? So like this is a structure aware, not just text splitting. For Python we use the AST module to walk walk the syntax tree and chunk one function or class at a time. For Java, Java long. For SQL, SQL. Like these are the modules. Uh, for chunks, AST for Python. For Java, Java Lang we use. SQL glot we use. This means when you ingest a 50 line Python file, the vector database stores the divide function as one coherent chunk, not an arbitrary 900 character slice that cuts a function in half. So I will show you in ingestion. See, in ingestions, loaders is there, no? In code loader here for to load Python files. See, to load Python, and this is for Java long module. Here you can see Java long AST for Python files, Java lang modules, and SQL files. SQL related anything is there. It will read SQL related like that. So Java, Python, whatever it may be, it will understand, right? And let's see the pipeline. What is the pipeline? Here, same in ingestion folder itself, the pipeline will be there. This one. What is this? One dictionary maps file extensions to loaders. This is the pipeline. Here, the entire dictionary, this is the type of dictionary maps file extensions to loaders. This is the entire ingestion router, simple by design. That's it. So here, see PDFs, XLS, text, SQL, YML. This will routes an input file to the loader matching its extensions. Whatever the input file you give, it will automatically load matches its extension. That's it. So up to phase 2 completed. Now let's see extraction completed, loading completed, extraction, chunking, loading completed. Now what to do? Now we have to create a database, knowledge layer. This is the big roadmap moment. That phase 2 of like after phase 2, this is the RAG specifically we created for knowledge layer. Knowledge layer here, see, in app, the knowledge layer is there. This is the knowledge layer. And here vector store. Here we have to store. We have to store the embeddings. We took ChromaDB. Running as a persistent client. What it means? Means it writes to disk, not just memory. Each source type gets its own collection, like code Python, code Java, QS, like QS standards, accept shoots, and so on. So like that, it writes to disk. Each source type gets its own collection. So here it stores. Next, what? That we have to retrieve, right? So this is the retriever code. What it is? Let's see. Here, this is the real RAG implementation, and it's not just embedded and cosine similarity search. Here, 3 stages. One is dense vector search, a keyword overlap search, then reciprocal rank fusion to merge both rankings, because dense search alone misses exact keyword matches, and keyword search alone misses semantic similarity. Then an LLM re-ranks the fusion results for final relevance. And if the retrieve results don't actually overlap with the query, a corrective step rewrites the query and retrieves once. That's corrective RAG, a real technique, not something I made up for this video. This is the real technique. Here, see. Hybrid retrieval with RRF function. RRF function, I already re-ranking fusion. I already told. LLM re-ranking. And one corrective query rewrite try when retrieval overlap with the query is weak. And what next? Vector, you store the embeddings in vector, and retrieve, have to retrieve. Next, what is this? Seed.py. What is this actually? What is this? This seeds a QA standards collection with the boundary value rules like an OWASP aligned security checklist for suppose ETL reconciliation standards and testing best practices. So Every generated test suite is grounded in real QA knowledge, not just the LLM's raw guess. So here, what it is, the standard boundary value analysis for every numeric or length boundary field, generate cases at minimum like this. So security checklist, what is the OWS align checklist? Cover injection, SQL command, LDAP, broken authentication session, like this. These we have to do some analysis, do some analysis, and we have to implement this seeding, right? Okay, knowledge seed completed. Now what? What next? The agent core, LangGraph, what it is. Here, the planner, executor, validator, multi-agent pattern. Here it comes. Next, the phase 4, the agent core. It Here it comes planning, executing, and validating. Let's go to agents. The multi-agent pipeline, right? We created. Now let's go to agents. App only agents is there. Yeah, sorry. Here. What is this? Let's see the state. What is the state means? Shared LangGraph pipeline state. What is the state? Here, a typed dictionary. This is the shared memory that flows through every node of the graph, like short-term memory in generative AI terms. That's it. Simple state, nothing but a short-term memory in generative AI terms. What is this state? Though state remembers acts as a temporary memory. Shared LangGraph pipeline state. Now, let's see the router. What is this router? It is a deterministic routing by file extension first, falling back to keyword detection in the text. Why deterministic instead of asking an LLM what kind of file is this? Because it's free, instant, and 100% reliable. Never use an LLM call for a decision a regex can make correctly. So that's why. So router, it is deterministic engine routing by file extension with a keyword fallback for inputs supplied as raw text only. The like paste requirements or ETL descriptions, it 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 detects automatically. That is for router. And what is this planner? What is this planner actually? Planner, validator, risk. Let's see. Here, this in the planner file and analyzer file and validator file and risk file. Here, planner is there, analyzer is there, analyzer, and risk, and validator also there. Where is the yeah, validator? These are the This is the multi-agent pattern from like some type of AI engineering. Here, a planner decides scope and case budget. What planner will do? See, engine default budget, engine collections. Engine will collect manual or Python or Java or unit SQL or ETL related or API related. It collects and it decides scope and case budget. Next, what the validator will do? Here, not validator. Once plan was happened, it should analyze. An analyzer extracts structure, functions, endpoints, mappings. So here, engine awaits structure extractions followed by corrective retrieval. What if extract modules, actors, features, everything like this? It will analyze it. This is the one agent. This agent will analyze it. Planner agent will decide scope and case budget. Analyzer extract structure like functions, endpoints, mapping. And next, what? It should validate. A validator checks the output against the engine specific rules and can trigger up to two retries. Validator. One second. Yeah, this is the validator. What is this validator means? Engine aware validation gates with a bounded retry loops, maximum two times. So checks the output against engine specific rules and can trigger up to two retries. And what is the risk.py? Here a risk tagger flags anything touching authorization, payment or PI as high priority. So here risk also we take care of that. Now let's see what about the graph.py here. What is this graph.py? Why? This is the main. This is where LangGraph assembles all of it into a state mission like router to planner, planner to analyzer, analyzer to engine, engine to validator with a conditional edge. If validation fails, loop back to the engine node up to twice. Otherwise, proceed to risk tagging and end it. This conditional retry loop is the single most agentic piece of this whole system. This is the this is all about assembles the this agent LangGraph pipeline. Now let's move into phase 5, the 6 engines. Where those are like engines. Here close the agents and engines. Here engines. What are these 6? Here first let's see manual cases. What is this? Here, LLM driven manual test case can generate across all disciplines. What is this? Each engine is one prompt plus one strict JSON schema. Notice the schema hint. Here at the top of the file, we explicitly tell the model the exact JSON shape we want. That is all about manual JSON, manual test case JSON. Here, here like JSON mode bug story here a great concrete war story. For suppose here's a real bug we hit. The SQL engine kept failing validation. 3 retries in a row. Silently, when I inspected the raw model output, it had generated JavaScript style string. Concatenation inside a Java string value, completely invalid JSON, and it wasn't consistent. Sometimes it worked, sometimes it didn't. The fix wasn't a better prompt. Prompts are problematic. The fix was switching to the provider's native JSON mode. That is all about manual test cases. Now, here, see, one second. In app, we already saw the configuration model. In the configuration model, what happened? Get LLM JSON. See, get LLM JSON. Here, what happened? The response format JSON object forces the API itself to guarantees like syntactically valid JSON. That's a structural guarantee, not a hope. This is exactly the structured outputs skilled from like phase 3 of the roadmap, what we already saw. Now let's see the memory caching. Here, memory, what happened here? Memory caching is there. Here, two caching layers exact match via SHA 256 hash of the normalized request, instant free and semantic match. If the embedding of a new request is at least 0.92 cosine similarity to a cached one, we treat it as a repeat. This catches near duplicate requests like someone retry with silently different wording. Now, for suppose 0.92 sounds like a arbitrary number, but I actually measured it. A heavily rewarded paraphrase only scored about 0.93 similarity, while a lightly rewarded near duplicate scored 0.99. So this result specifically catches basically the same request, not a loosely related topic. That distinction matters if you are building it yourself. So that's what this is semantic threshold. Now, now see here the pipeline. For suppose in agents we saw the pipeline. Where is the pipeline? Yeah, here. Here what we did. This wires catchy check, graph execution, catchy rewrite, and long-term memory together. Every accepted shoot gets pushed back into an accepted shoots vector collection. So future generations can learn from past accepted output. That's the long-term memory piece from phase 4 of the roadmap. Roadmap nothing but the file we created. Now let's see guardrails and exports. What it is? What is the guardrails? Here let's see. Here guardrail. What is this? Here rejects based PII masking like credit card numbers, emails, phone numbers plus prompt injection detection. And what is this? For suppose you run it against a string containing a fake card number and ignore previous instructions type. Both get neutralized before the text ever reaches the LLM. So that is called guardrail. So input guardrail and output guardrail also very important here. No worries. I will send you this code file, everything, Git repository, no problem. And here every engine output gets validated against a strict pedantic schema. If it fails, we reprompt once with the exact validation errors. This is a second independent safety net. The LangGraph validator checks business rules. This checks structural correctness. Now here see, now services. Services nothing but guardrails completed. What is this? What are the services means? Export files. Export files. Import. Export PDF. What is this? One real bug worth mentioning PDF export kept crashing with not enough horizontal space to render a single character. A deprecated FPDF2 API parameter wasn't resetting the cursor position properly. The fix was switching to the modern new X, new Y parameters. Small thing, but it exactly the kind of error you will hit with any PDF generation library. So recognize the pattern. So to recognize the pattern, that is important. Here you can export PDF. Here to recognize the pattern, we have to write the code like this. Now let's go to the phase 8, the fast API backend. What is that? Backend is very important. Now let's see where is that? In app only it will be there. In API. See here, this is the backend. The main.py. This is the main.py. Here we wired everything. Two ways to generate a synchronous generate endpoint that blocks until done and a asynchronous generates start plus pair option. Why both? Because generation can take 20 to 40 seconds. Completely blocking an UI for that long with zero feedback is a bad experience. So that's why here synchronous and asynchronous we created like this. This is the complete wiring here. Now here in agents, see here in agents we have jobs.py. Here what is this? This is what powers that live step tracker you saw in the demo, right? LangGraph has a native .stream method with stream mode updates that yields the name of each node as it completes in real actual execution order, not a simulated animation. We run that in a background thread and UA polls a status endpoint every 15 seconds. That's what. That's what jobs.py will do. And see here in API, we have rate limit. What is this? What is this rate limit? Like the slow API. What is this? The rate limiting exists so one client can't accidentally or maliciously burn through your OpenAI budget. This is rate limit. Rate limit to budget purpose. And let's see the phase 9 UI related. Here in Hackathon, we built this with Streamlit, but in personal laptop, we built with Next.js. But here, Streamlit, let's discuss. Streamlit is a thin client here. It holds almost no logic. It just calls the API and renders the response. All the real work happens in the backend, which means you could swap this UI for a React app later without touching the agent at all. So the visual design uses two techniques deliberately, not randomly, like glass morphism, translucent, blurred backgrounds, no large surfaces like panels and the sidebars, because blur reads as floating glass over content, and neomorphism. We used CSS style, soft embossed shadows and on buttons. See here. See, this is the glass morphism, neomorphism we use because the tactile shadow shifts communicates this is pressable. This is pressable. This is pressable like that, which glass doesn't. So this is all about phase 9. And let's go to phase 10, evolves and observability and Docker and CI related continuous integration. Evolves. What is evolves? Here, this is golden test. What is this actually? Here, 12 test cases, two per engine, each with expected properties, minimum case counts, required categories, required keywords. This runs against the live API and prints a pass file scoreboard. This is how you catch regressions before a user does. That's it. And now let's go to Docker here. What is this Docker? Docker file. Let's see Docker file. Here, what is this? See, notice the CMD line uses port 8000. What is that? Here, here, reading the port from an environment variable with a fallback. Cloud platforms like Render assign a dynamic port. Hard coding 8000 would have broken deployment silently. That's what. So this is about Docker. Nothing much. So just for introduction purpose, I am telling. Now let's see that dot GitHub. I will tell you dot GitHub related. Yeah. Here, what is this dot here? Here, three jobs are there, like lint and test on every push, evolves on main only because evolves cost real API money, and a Docker build gate after that. This is a real CI/CD pipeline matching phase, like real CI/CD pipeline. It will looks like this. We have to create GitHub CI pipeline like this. And later we deploy GitHub. We deployed this code to GitHub, um, and later Vercel, and we can deploy this to render or Vercel. We deployed nothing but hosted in render. The first question people ask, why not Vercel? Vercel is built for serverless functions, stateless, disposable, seconds long execution. This app needs a server that stays running continuously. So this needs some need server so for continuous running. Streamlit holds a live WebSocket connection. Chroma writes to desk that must persist between requests, and generation calls can run 40 plus seconds longer than virtual function timeout on most plans. So render runs actual long-lived containers from a Docker file, which is what this architecture needs. So that's it. So here deployment flow is the deployment flow I will show you. First, we have to use gh repo create, push to GitHub. Later, open render.yml, a blueprint. Here, I will show you. Here, one a blueprint you have to open. Render reads this file and proposes both services automatically. And let's go to the dashboard. Here, see here, blueprint creation linking the GitHub. I linked this blueprint uh, with the here. Here we can link with repositories. See here we can get with link with GitHub. So here we can connect here. These are the repository I have. We can connect with the repository anything. So first our code we should push to the GitHub. Then those GitHub related we can push to GitHub, GitLab or Bitbucket. Anything is a version control tool. So cloud hosting version controls. Here we automatically whatever the repositories you have, it will reflect here. So blueprint nothing but the code copy. So I connected that and hosted and connected and hosted. It will show like this. Test QA test case generator agent. Right. That this is another project. Two projects are there. It is showing this is another project. This is first project. So and also once you pull that code into render, what next? Later we have to set the, for suppose here you have to we have to set the API keys and everything, environment variables. Here we have to set the way, again you have to set all the API, open API key, everything. Actually in production sometimes like in production practice, the best practice production engineering is like after deploying every single generation failed with APC connection error, like connection error, but a plain HTTPS request to OpenAI succeeded. That that told me the network itself was fine. Something was wrong specifically with authenticated requests. I opened a shell here. This shell is there. Actually, this cell will open for paid version. So at that time, I paid some ₹2 like that. I authenticated request. I opened a shell into the running container and made the exact same request curl makes, and the real error was legal header value with a visible backslash and at the end of the APK. So somewhere between copying the key and pasting it into render's dashboard, a trailing new line got included, and HTTP reads can't contain new lines. The fix was twofold. Like fix the value in the dashboard and add dot strip validator in the settings loader. So this class of bug can never silently recur on this platform or any other. And also I experienced some Jira URL bug story. A user pasted a full Jira URL into a field that expected just the issue key and got an opaque for 500 error. Two real fixes here. A rejects that extracts the key from either a base string or a full URL and converting every unhandled exception into a clear 4x response instead of a raw crash. Good error handling isn't just catch the exception. It's catch it and tell the user something they can act on. And environment groups, I already told. Environment groups, what these are. Instead of setting the same variables on every service individually, here you can create separate environment variables. Renders lets you create a shared environment group. I created a shared environment group. I will show you. See here. Yeah, here I created a shared environment group. Instead of setting the same variables on every service individually, render lets you create a shared environment group. Link it once, and every service that needs it gets the values and updates propagate everywhere it wants. So this is all about what we build, the project, everything. Just ask me any questions you have. I will assist you. Just make sure with the folder structure, guardrails, .env file to maintain the environment variables, folder structure, everything, and make sure the application should function while judges coming to evaluate anything. So it should function, it should show result, and team coordination should be there. So each in hackathon, nearly 5 members as a team will participate, and one mentor will be there. So mentor can assist anything. Mentor can assist. So you can take the help from mentor, and 5 people each role what they have to tell explain to the judges they should fix. One should explain about front end, one should explain about back end, one should explain about guardrails, one should explain about data, why I prepared data related things and I prepared PPT related things, like that. Everyone in the team should fix it their roles in front of the judges while they came to you. You have to be clear what you did. So everyone should talk, so then they will get impressed, and definitely you will won the hackathon if you execute the result properly, if you show the result to the judges, like that. So now Now we went from an empty folder to a deployed working Gen AI agent platform and 6 engines, real RAG, a genuine multi-agent LangGraph pipeline, caching, guardrails, CI/CD, and a live deployment with real production bugs fixed in public. If this is the kind of project that gets you through your next hackathon, subscribe, and I will see you in the next one where we go deeper into agentic tool calling and fine tuning. Thank you so much. Until then, stay tuned to the channel.